Hey everybody, Mr. Morel here, and today in this video I'm going to be talking to you about our very first homework assignment, which is basically just reviewing operations. Now, you wouldn't think that operations had that much to review, but there's plenty. So we're going to go ahead and jump right in and do that. So the first thing I want to talk about is what the heck is an operation? So an operation is a way of putting two numbers together. It's basically if you have two numbers and you put a symbol in between, you want different stuff to start happening. The most common operations that you know about are addition, subtraction, multiplication, and division, but there are a lot more, and we'll talk about a few more this year, and then you're going to learn about a lot more when we get to the high school, or when you get to the high school. So one thing that's going to be really important is something called the order of operations. And I know that you've heard about it in the past. They've been talking to you about it for years. And depending on the person, there are different ways to remember what the order of operations is. And that's kind of like a fancy term, but I just want to make sure that's clear. Order of operations means the order that you should do operations when you have several operations together. So I think in this school district, most people usually remember it just as PEMDAS. And then I know that when I was growing up, we were told to remember, please excuse my dear Aunt Sally. Whichever way works best for you. The big point is that you're supposed to kind of remember that when you see an expression, we're going to talk about that in a second, the first thing you should always look for are parentheses, and you would take care of parentheses first. And then exponents, and then multiplication, and then division, addition, and subtraction. Now, something that I want to talk about is we're going to always keep things in that order right there, but it is worth noticing that multiplication and division are kind of on the same level. Like you could do those if you just have multiplication and division, usually people go left to right. And same thing with addition and subtraction. If you only have addition and subtraction, then you want to go left to right. You don't have to do addition and then subtraction. They just list them in that order so that things are nicer. So one question that I get a lot from students who struggle with math especially is, well, why does this even matter? Why do the operations need to be in a specific order? Well, let's start with this question right here. If we have 2 plus 3 times 4, it's really natural for people to want to do things from left to right. And especially in this example. So, like, let's say that you are reading a story problem. I'm just going to make it up. And they say you have 2 apples and 3 boxes of 4 apples. Okay, so let's think about that. If you have 2 apples and then you have 3 boxes of 4 apples, I want you to think, how many apples would you get, and get an answer in your brain. But if we were to do these operations from left to right, so if we did 2 plus 3 first, that would be 5. And 5 times 4 is, so let me draw some lines here. 5 times 4 ends up being 20. Well, if you're thinking about our apple example, you probably didn't get the number 20. 2 apples and 3 sets of 4 apples wouldn't be 20. That would actually be something different that we would get from using the order of operations correctly. So let's do this again. 2 apples and 3 sets of 4. Probably you want to start with 3 sets of 4 apples. Well, if I have 3 sets of 4 apples, that would end up being 12. And we had the 2 that we started off with. So the reason order of operations is helpful is a lot of times if you're reading a story problem or thinking through something logically, you would sometimes write operations in a weird order. But to help us always get the same answer no matter what we do. So for example, in this, we wouldn't get 20, we would get 14. Well, we need the order of operations to help us organize stuff so that 2 people who are looking at this one expression here don't get different answers. So again, just to recap, if I had this expression, I don't see any parentheses, so I don't need to worry about that. I don't see any exponents, so I don't need to worry about that. I do see multiplication, so I'm going to start there. 3 times 4 is 12. I don't see any division, so we're going to skip that. And finally, we do have addition. I'm going to bring down this 2 plus. So 2 plus 12 is 14. And that would be how you would simplify this thing here, which is called a numerical expression. Now, just because we're here and we're talking about these apples, maybe I did want somebody to add 2 and 3 together before multiplying by 4. Let's just say that you wanted someone to do that. Well, what you would need to do is find a way to make the addition happen before the multiplication. So if you want to have the addition happen before the multiplication, that means that you've got to somehow you've got to pick an operation up here above the multiplication. So like maybe the story problem is something like you have 2 apples and 3 bananas in 4 boxes altogether. So like each box has 2 apples and 3 bananas. You've got 4 boxes altogether. How many fruits do you have? Like, I'm totally just making this up. Well, you might think, okay, well, I have 2 apples and 3 bananas, and I need 4 sets of those. Okay, so you would write this out, but again, we talked about this. Order of operations means somebody doing this would end up getting 14. So the way that I would try to get someone in this example to add before multiplying is, in my brain, I'm thinking, well, what if we put some parentheses in there? What if I put some parentheses just like this? Now, if I needed to solve this problem, I have to do the parentheses first. So I would have to take care of 2 plus 3, which is 5. And then, no more exponents, so we would do our multiplication part. 5 times 4 is 20. Okay? I know that's a little bit confusing, but we're going to practice in this video, and we're just going to, that's one of the rules about math. It's one of the first things you learn is not only are there operations, but you've got to actually solve them in an appropriate order. So keep that in mind. We're going to come back to some more examples really soon. But I did want to talk about something else here. What do operations look like? Well, here are your 4 basic operations. Of course they look like that. But something that's going to become really tricky in 9th grade is this idea that there are other ways that these operations look. So, for example, 4 plus 5. Cool. You might think that there's no other way to write that, but there is another way to write that I'm going to talk about in a second. 4 minus 5. Okay, again, you're thinking, well, yeah, how else would you write that? Well, here's something that's going to be so huge for us in 9th grade. I personally, like me, Mr. Morell, I am really bad at subtracting. And so something that I learned really early on, because I'm so bad at subtracting, is that you can actually change a subtraction sign. So here's the rule. If you are bad at subtracting like me, you could change any minus sign to say plus, as long as you change the sign of the thing that comes after it. So what I want to say here is that 4 minus 5, a different way to write that is 4 plus negative 5. And if you don't believe me, go check your calculators. You're going to get the answer that both of these, 4 minus 5 and 4 plus negative 5, those are both negative 1. Okay, so that's kind of a general rule for subtracting, is you can change a subtraction sign as long as you change the thing that comes after it. Well, let's think about this. If I have 4 minus negative 5. Okay, so let's follow my logic. You can change a minus sign, because sometimes you're going to see subtracting a negative, and that's really confusing. You can change that to say 4 plus, but you also have to change the sign of the thing that comes after it. So 4 minus negative 5 is actually the same as 4 plus a positive 5, which is crazy. And in fact, hey, look, isn't that the same as the thing we've got over here? So what I'm trying to get at with this example is that another way you could write 4 plus 5 is, oh, let me pull up my pen. You could actually write this as 4 minus negative 5. Now, chances are good you wouldn't really want to write this, but throughout the year, you're going to see examples where this thing shows up, and what I'm trying to show you is that you could rewrite 4 minus negative 5 to be 4 plus 5. Those are the same thing, all right? So a little bit tricky, but we just found 2 ways to write adding. We have 2 ways to write subtracting. Oh, and I should probably add over here that this number would be a 9. And again, you're welcome to use your calculator and check me on that. Okay, 4 times 5. Now, we're not going to get too fancy like this, but I do want to cover some bases. 4 times 5, sometimes you'll write it with the x, but all year we're going to be using the letter x as a variable, and so we don't want to get that too confused. So you're going to see a lot of times people just use a dot. So the dot multiplication symbol is going to be really common in 9th grade. But you're also going to be using a lot this idea about parentheses, that if you have parentheses around something, so I'm going to, sorry, drawing this is a little tricky. So 4 parentheses 5 parentheses, just like this, is the exact same thing as 4 times 5. So if you ever have a set of parentheses and a number right in front of it and no symbol, that means you should be multiplying that. All right, so those are some examples of what multiplying looks like. Okay, now let's talk about dividing. Obviously 4 divided by 5. In 9th grade, you will almost never see the division symbol. It just doesn't come up. Like as you kind of get older, you drop the division symbol. A lot of times you're going to see things like 4/5 like this. But more commonly, you're going to see basically a fraction. So the fraction 4/5 is the same as 4 divided by 5. And I mean, I'm going to try to blow your mind here for a second. Take a look at what a division symbol looks like. It's a line in the middle with something on the top and something on the bottom. So line in the middle, something on the top, something on the bottom. That's the division symbol. And hey, look, that is what a fraction is. A line in the middle, something on the top, and something on the bottom. So the fraction 4/5, another way to read that is 4 divided by 5. Okay, so we've covered some really basic things that are going to be coming up this year that in theory you already learned. Oh, and just to be consistent, 4 times 5 is 20, and 4 divided by 5 is 4/5, if I was to ask you that. It's also a decimal number. It's actually 0.8, but we're going to avoid decimals a lot. We're going to stick with fractions for first trimester. 4/5 would be a better answer there. Okay, with that said, let's move on. What if we wanted to simplify these expressions? Well, I'm going to use the hints that we just barely looked at on this page. So if I see 2 plus -3, that might be really confusing for me that way. And so maybe we want to rewrite that as 2 minus 3. And 2 minus 3 is -1. It's all the way simplified, down as far as it can go. 2 minus -3, if I look back at this chart, it's the same as this one. I could rewrite that, change the subtraction, and change the next sign. We could rewrite that as 2 plus 3, which is 5. All right, easy enough. Let's go to this one. I put on the order of operations so we can see it better. So if I want to simplify this, I don't see any parentheses. I don't see any exponents, but I do see multiplication. So 3 times 4 is 12. And then let me bring down the other stuff. Notice how I'm showing my work. You're going to be expected to show your work on your homework assignments as you turn them in. No division, no addition. Unless you wanted to change that to say plus a negative, you could do that. And then subtraction. 2 minus 12 is -10. Notice how I'm showing all of my steps on the screen. That's because as you do your homework assignment, I expect you to show all of your steps. I want to see things like the things you're seeing on the screen. Okay, let's try this one now. Now, I made this question. I have the same expression 2 times because I want to show you you can actually take care of parentheses in 2 different ways. So the common way that we've been doing is if we're taking care of the parentheses, we could just combine the stuff in the parentheses first. So we could do 3 plus 4, which is 7, and 2 times 7 is 14. Or there's another way I wanted to remind you. I'm pretty sure you did it a lot last year. Another way to take care of parentheses is by doing something called distributing. Remember how we talked about there's an invisible multiplication symbol right here. So if you see 2 and then a set of parentheses with the 3 and the 4, that means that what you should do is you should take the 3 and the 4 and multiply both of those numbers by 2. So we're going to do 2 times 3, and we could do 2 times 4. Okay? So I usually call this the Santa hat. I think I've heard other teachers in the intermediate school call it do the rainbow. I call it a Santa hat because you can see it kind of looks like a Santa Claus hat. So 2 times 3 is 6. 2 times 4 is 8. And now there's no more parentheses, no exponents, no more multiplication, no more division. We're just going to add those together to get 14. Both ways are correct. You can tell they're both correct. We got the same answer both ways because we followed order of operations. So when you see parentheses, sometimes there's 2 ways to take care of it. Same thing with a fraction. So one thing I wanted to point out is when you have a fraction with a few things on the top or the bottom, there are actually some invisible parentheses hiding. It's basically these invisible parentheses on the top kind of gluing those things together. That's what this line is doing. It's trying to keep those things together. And so if I was going to solve this using order of operations, invisible parentheses here means I would need to start with the parentheses. So 8 minus 10 is negative 2. And then think about it. Now we have the fraction negative 2 over 2, which is division. So negative 2 divided by 2 is negative 1. So that's one way to solve this. There's actually a different way to solve this. Let's see if this looks familiar to you. I think a lot of teachers will often draw these heart-shaped things, and I'm going to try to get the negative in there. A lot of times you'll see a picture like this, only prettier. And that means that both of these terms, the 8 and the negative 10, need to be divided by 2. So we're going to do that one at a time. 8 divided by 2 is 4. And then we've got a minus symbol. And you could either think of that as negative 10 divided by 2. Anyway, I don't want to get too complicated, but yeah. So 10 divided by 2, we've got the negative right here, is 5. And 4 minus 5 is negative 1. Okay? So that is 2 different ways to handle a big fraction like that, just as your review. All right, let's get a little tricky here. Simplify this expression. Now, you could do this a couple different ways. I think I'm just going to keep it simple. You could distribute the 3, but what I want to say about this is if you're going to distribute the 3, you need to remember that this is a negative 3 in the front. So if you're going to distribute the 3, I would recommend changing this to say plus negative 3. Okay, I'm going to do this both ways, so don't get overwhelmed. I could change this to say plus negative 3, just like we were talking about. So we would have 2 plus negative 3 times 4 is negative 12 plus negative 3 times 5 is negative 15. Oops, I wrote that really terribly. And then from left to right, you would add stuff together. So 2 plus negative 12 is negative 10. Oh my gosh, this is gorgeous. Look at that writing. And negative 10 plus negative 15, or you could say negative 10 if you want to, negative 10 minus 15, because adding a negative is the same as subtracting, like we talked about early on in this video, and that would end up being negative 20. So that's one way to solve this problem. Let me clear the ink. I'm going to solve it probably the way that you would solve it. Let's take care of the parentheses first. 4 plus 5 is 9, so we're going to have 2 minus 3 times 9. Okay, now no exponents. Let's take care of the multiplication. Again, I love math because there's so many ways you could do stuff. You could think of that as a negative 3, or let's just write that minus sign and do 3 times 9. Okay, or what I was trying to say is that you could do 2 plus negative 3 times 9 is negative 27. Did I do that right? Yeah, I think I did. Negative 3, yeah, okay. And then we've got that negative 20. Hold on, I messed up on the last one, didn't I? Hold on, let's undo this really fast. Undo, 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 undo. Where did I mess up? That's negative 12. That's negative 15. We're going to add those together. So that was negative 10. Oh, why did I change that number? Oh my gosh. I will make a note of that. That's negative 25, guys. That is negative 25. I will write a note. I promise. Sorry. Okay, now let me clear the ink. Part of how I knew I was wrong is I was trying to do it a different way and I got a different number. That's embarrassing. I'm not even going to edit that out of the video because even teachers make mistakes sometimes. Okay, so what were we doing before? We were combining these. So we had 2 minus 3 times 9. So we're going to do 2 minus 3 times 9 is 27. And 2 minus 27 is negative 25. Or if it's helpful, you could have thought of that as plus negative 27. Same thing, you'll get negative 25. Okay? Sorry for that goof. It happens. It happens all the time. So here we go. All right, let's try this question. Once again, I could do a couple different things. I could divide both of these terms by 2, and then I could put stuff together. But just to remind you that that's like invisible parentheses up there, let's draw those in and take care of that part first. So parentheses, 6 plus negative 12. Okay, well that's the same as 6 minus 12 if it's easier. I don't know what's easier in your brain. Probably everybody has a different way of seeing it. 6 minus 12 is negative 6. We still have divided by 2. Notice how I'm writing all of my work down. Oops. Negative 6 divided by 2 is negative 3. Use your calculator, no big deal. And negative 3 minus 10 is negative 13. Now, especially knowing that I make mistakes, I'm going to try to solve this the other way, and let's see if we get the same answer. So 6 divided by 2 is 3. Plus 2 divided by negative 12 is negative 6 minus 10. All right. Now, if you want to, you could change this one to say plus negative over here, or we could change this one to say minus. Whatever's easier for you and your brain. Adding a negative is the same as subtracting, and that's going to come up over and over and over again this year. So this is kind of a practice assignment for that. You could just type this in your calculator if you want. I'll go one at a time. 3 minus 6 is negative 3. So we've got negative 3 minus 10. And negative 3 minus 10 is negative 13. Same answer. I actually got that one right both times. Yay me. That's not a B down there. That's negative 13. All right. So that was basically your lesson. I did a couple of practice ones. In most videos, I will do some hints about the level 3 question and the level 4 question. But I was actually planning ahead. The level 3 question and the level 4 question, I actually planted hints for those questions in the earlier parts of this video, so I want to see how much you can take what I talked about in this video and apply it to these tougher questions here. Anyway, that was your first video, mini lesson. Hopefully it made all of your dreams come true, obviously. Good luck on your homework assignment. Don't forget, you can check your answer 3 times on every question, so you could just type in your guess, check the answer, see if you're right or not. But the other thing to remember is I have hints at the bottom of those questions, so you can also get some hints. And I'll just type out some hopefully helpful stuff there. All right, thank you guys for watching. Good luck on your assignment, and I will talk to you later. Bye!